Hello everyone, in this video we're going to talk about the square root functions. A square root function is a function where the variable is inside the square root, right? Now, a square root function is the inverse of a quadratic function. It starts from the origin and increasing slowly to the right, right? The domain of the square root function is s greater than or equal to 0. And the range is going to be y greater than or equal to 0, right? This one is the x-intercept and the y-intercept, right? Now, we're going to talk about the vertex form of the square root function. This form is also used to do transformation, right? Now, if b greater than 0 and a greater than 0, the square root function has this direction, right? Domain is going to be from h all the way to the right, right? The range is going to be from k all the way up, right? This one is the vertex h and k, right? Now, if a less than 0 and b greater than 0, it's gonna go this way, right? And domain from h all the way to the right, and the range from negative infinity to k, right? Now, if a greater than 0 and b less than 0, it's going this way, right? Domain is going to be from negative infinity to h, and the range is going to be from k to positive infinity. And the last one, b less than 0, a less than 0 is going this way. Domain is going to be negative infinity to h, and the range is going to be negative infinity to k, right? Now, how do we graph the square root function? We're going to use the vertex form to graph this one. Step number 1, we need to rewrite the function in vertex form and find the vertex, which is h and k. Step number 2, determine the side of a and b, and thus direction of the function. Step number 3, create a table of values for additional points. Step number 4, plot points and connect the dots. We're going to use the vertex form to do the transformation. Alright, remember the order of transformation is b, h, a, k. And I have a trick for you to memorize this order of transformation. Alright, we're going to start with b first. B means horizontal dilation by a factor of absolute value of 1 over b. If b between 0 and 1, this is called horizontal straight. b greater than 1, this is horizontal compression. Now, next one, h represents the horizontal translation. h greater than 0, shift to the right, absolute value, h units. h less than 0, shift left, absolute value of h units. Alright, keep that in mind. This guy right here means h positive, right? If you see the plus h like this, which means h negative. So keep that in mind. Now, we're going to move on to the next one, a. Represent vertical dilation by factor of absolute value of a. A greater than 1, vertical straight. A between 0 1, vertical compression. And the last one, k, vertical translation. K greater than 0, shift up, absolute value of k units. K less than 0, shift down, absolute value of k units. Right? Now, if a less than 0, reflect over the x-axis. b less than 0, reflect over the y-axis. Note that anything related to variable x, you're going to do opposite. Now, the last one we're going to talk about is the inverse of a square root function. To find the inverse of the square root function, we use the same method as finding the inverse of any function. Alright, please check out the link in the description below to learn how to find the inverse of any function. Now, square root function and quadratic function are not the exact inverse of each other. There should be domain and range restriction, so keep that in mind. The domain of a square root function becomes the range of its inverse and vice versa. The inverse of a relation, not a function, because we must consider the positive and negative solution when taking the square root, which is not the case in square root function. Alright, let's take a look at the first example. Given the function h of x equals this guy, we need to graph this one. Alright, so how do we graph? We need to locate the vertex, right? So, we need to rewrite this one in the vertex form. It's going to be negative 2 square root of factor negative 3 out. Right? So we have x minus 4, right? Minus 2. So the vertex is h and k. H is 4 and k is negative 2, right? Now a is negative 2 right here, right? And b is negative 3 right here, right? So since a is negative and b is negative, we're going to look at the note right here. It's going to be this guy and this guy. The function should be something like this, right? Now we need to locate the vertex on the x and y coordinate plane. It's going to be 4 and negative 2, which is right here, right? And you know that the function goes this way, so keep that in mind. Now we need to create the table of values. This is s, this is h of s, right? First s equals 1, so we have h of 1. It's going to be negative 2 square root of negative 3 times 1 plus 12 minus 2, right? So it could be negative 2, negative 3 plus 12, it could be 9, square root of 9 equals 3, right? Minus 2. And it's going to be negative 6 minus 2, negative 8, right? So s equals 1, y equals negative 8, which is right here, right? Now x equals 2. So we have h of 2 equals negative 2 square root of negative 3 times 2 plus 12 minus 2, right? So it's going to be negative 2 times negative 6 plus 12, it could be square root of 6, right? Minus 2, right? It's going to be negative 6.9, right? So it's close to 7, right? So x equals 2, y equals negative 7. It could be something like this, right? Now what if s equals 0? So we have h of 0, and this one is the y-intercept, right? Negative 2 square root of 3 times 0 equals 0, right? So it could be 12 right here, minus 2, right? Now 12, we can split this one in 4 and 3, right? Print 4 outside, it could be 2, right? So we have negative 4 root 3 minus 2, right? It's going to be approximately negative 8.9, right? So negative 8.9 is close to 9, so it could be somewhere right here, right? Now if we connect these points and we get the graph of the radical functions. The domain is going to be from negative infinity to 4, right? And the range is going to be from negative infinity to negative 2, right? The x-intercept is none, right? Now y-intercept is going to be right here, right? So x equals 0, y equals negative 4 root 3 minus 2. Make sure you write the exact value, right? Now question C. Perform the transformation from f of x equals the parent function to h of x equal this guy, right? Rewrite this one in vertex form. It's going to be negative 2 square root of negative 3 x minus 4 minus 2, right? Alright, we need to follow the order B, H, A, K, right? Now, step number 1, we need to do B, right? So B is 3 right here. So the first one, it should be horizontal dilation by factor of 1 over 3, right? Now, B is negative 3, right? Then, we need to do the reflection over the y-axis, right? H is 4, right? Then this one is horizontal translation to the right, 4 units, right? Now A is -2. We're gonna do vertical dilation by factor of 2 and reflect over the x-axis, right? A is -2 right here. We're gonna shift down 2 units, right? Now, question D. Find the inverse of h of s and graph both on the xy coordinate plane. Restrict the domain and range so that both are functions. Alright, so we know that h of s is -2 square root of -3s plus 12 minus 2, right? Alright, in order to find the inverse, we just swap s and y values. So this guy becomes s, right? And this guy becomes y. Alright, now we just isolate y, right? So we're gonna add to both sides. It's gonna be s plus 2 equals -2 square root of -3y plus 12. Divide both sides by -2, so it could be s plus 2 over -2, right? Equals square root of -3y plus 12. Square both sides, so it's gonna be -3y plus 12 equals s plus 2 over -2 altogether square, right? And this guy turns out to be 1 over 4 times s plus 2 square, right? Now subtract 12 both sides, so it will be -3y equals 1 over 4 times s plus 2 square. Subtract 12, right? Divide both sides by -3, so y equals -1 over 12, right? S plus 2 square and plus 4, right? And it's gonna be f. Now the last step, you're gonna replace y with f inverse, right? Now we're gonna wrap this one on the x and y coordinate plane. Now remember, this one is the graph of the original function, right? So the vertex right here is gonna be -2 and 4. Now look at the vertex right here, it's gonna be 4, -2. And the inverse, we just swap it, right? It makes sense, right? So x equals -2, y equals 4. It should be right here. Now I'm gonna let x equal 0, right? Substitute over here. So you have -1 over 12 times 2 square equals 4 plus 4, right? It's gonna be -1 over 3 plus 4, right? It's gonna be 3.67, right? So x equals 0, y equals 3.67. This is 1, 2, 3.67, so it could be somewhere right here, right? Now by symmetric, we have the reflection point of this point over the axis of symmetry, right? So it could be somewhere right here, right? Now we just connect these 3 points and we get the graph, right? The new domain of this guy right here should be from -infinity to -2, and the range should be -infinity to 4. Now remember, domain of the original function is -infinity to 4, right? And the range should be -infinity to -2, right? Now this restricted domain only gives us the half of a parabola. This is because when we're talking about the square root function, we only take the positive root by definition. That's why you only have this range, right? Now let's move on to example number 2. Write a square root function given the graph with a vertex 3, -2, and passing through the point -1, 2. And we look at the graph here, it's going this way, right? So we look at the note right here. It tells us that A positive, B negative, right? So we have A positive, B negative, right? So we have f of s equals a square root of negative of s minus 3 minus 2, right? Now use this order pair right here to solve for a, right? So 2 equals a square root of negative 1 minus 3 minus 2, right? Add to both sides, so we have a square root of -1 minus 3, -4 times -1 is going to be 4 equals 4, right? Square root of 4 equals 2, so we have 2a equals 4, right? A equals 2, right? So we substitute back over here, we have the equation f of s equals 2 square root of negative s minus 3 minus 2, right? Now we're going to use the calculator to check our work. I'm going to add graphs right here and input this one and hit enter. It's going to be right here. Now example number 3, we do exactly the same thing, right? So we look at the graph, it's going to go this way, right? So we go back over here, A is negative, B is positive, right? The graph is right here. Alright, so we're going to use the vertex form f of s equals a square root of s minus h plus k, right? Now this is h and k, right? So substitute over here, f of s equals a square root of s minus 5 plus 12, right? And we use the order pair right here, right? So s equals 30, y equals 0, right? So we have 0 equals a square root of 30 minus 5 plus 12, right? So this guy turns out to be 30 minus 5 equals 25, right? Square root of 25 is 5, right? So we have 5a plus 12 equals 0, right? Subtract 12 both sides, so 5a equals negative 12 and a equals negative 12 over 5, which is negative, right? Substitute this guy back over here. So the final equation f of s is, we're going to use the calculator to check our work. Hit tab, input the second function, and hit enter. It does show up, you need to restrict the domain, right? So go to menu, window zoom, window setting right here. The minimum of s value is 0, the maximum is 20, right? And y minimum is 0, y maximum is 20, right? Hit enter. It's going to be right here. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand